All right, Java 4, lesson 4. And today this is kind of like the second part to the other lesson. So remember that I split it in half because I thought like otherwise it would be too much if we just squashed the comparing methods lesson together. So I split it into comparable and comparators. And today we're going to learn about comparators, which is another type of compare methods. Okay, so just a little definition first. So comparator is something you can use on a tree set or tree map to change ordering of things. So this is essentially very similar to comparable, which we used last time, right? But the thing with that is that comparable was used more for classes instead, because remember that comparable is an interface, right? And the thing what you did with that was that we said implements comparable angle brackets and then had data type inside of it. But that's specifically for classes more. And so it's not the same thing if you wanted to, for example, only switch integers, right? Integers are primitive data types, and that's from Java 1, but they're primitive data types. So that means that they already have an ordering built in, and they're not a class that you can really create. So therefore, what you have to do is use a comparator. And again, like it says, you can use this for numbers, strings, and so on. For strings, you'd have to use the string compared to method to be able to order it properly. So remember how last time I was kind of talking about how you can use the already built-in string compared to method to reverse the ordering of things. And that's kind of what I'm talking about here. You would kind of use the one that's already built in to swap everything. Okay, so yeah, the slideshow itself is short, and oh no, give me a second. Trouble getting out. Okay, but this is the document that leads to this document. So there's a decent amount of examples here, but that's because there's a lot of different ways to implement this. So let me just see if I can zoom in a bit more. Okay. So yeah, comparator. And again, comparator is an interface as well. It's just used differently. So one thing that needs to stay the same is the fact that you need to use import java.util. That's also for the tree set thing, right? Because tree sets need the import java.util. The important part that we need to focus on is here. So you can see that this looks essentially pretty much the same thing as comparable, right? You're doing the same thing. You're saying implements and then you're saying comparator. In this case, there's a difference because it's comparator instead of comparable now. And then the thing with this, right, is that instead of putting the class name, right, remember how comparable we had to put the name of the class inside the angle brackets? Well, now we're specifying integer, a primitive data type integer, as the data type that we're putting into comparator. And that is probably one of the key differences. And that's kind of what you need to do for everything to work. And then another key difference here is notice how it's not compared to now, it's just compare. So that's another key difference that it is important to make to differentiate between the two, comparator and comparable. Another difference is the fact that instead of just having one parameter like comparable did, now we have two parameters that are passing in. So one of them is an integer, the other is also an integer. So the point of this is to pass in two things that we want to compare. So that's kind of another key difference that you might want to note down, just because now we're passing in two things to compare. Another thing to notice is notice how this integer right here and this integer right here is completely matching, right? Those are the exact same. And it's similar to the way comparable had worked before as well. You need to match whatever you put inside the angle brackets with whatever is here. So if you put a string here, then you should also put a string here. If you put a double here in these angle brackets, then you should also have the word double for these two. So it's kind of a corresponding thing. And then this part should look pretty familiar because it's essentially the same thing as the comparable. you're doing the same thing. You're essentially using conditional statements to compare if these two values that you're passing in. And then you're returning either -1, 1, or 0, just like you're doing with comparable. And again, these all signify the exact same thing as that comparable did, right? So -1 means that this value right here, like the beginning variable, should be ordered lower. And then the 1 means that the B variable should be organized higher, I believe. Or sorry, no, I'm confusing you guys. The A variable should be sorted higher than the B variable. So yeah. And then of course the 0 just means equal, neutral. It will essentially always equal that. Like it'll always be that. All right, but that's one thing. And what happens with this is that if you create a tree set and then you say integer, right? Like we're specifying that we want a tree set of integer. The thing here to note is that now instead of having just like empty parentheses like we've always essentially had before, now we're creating a new object of random, right? Remember, like this is like the latter part of creating an object, right? It's the part after the equal sign. This is essentially the new random part, like creating a new object. And that's because essentially by creating new random, you're saying that I want to use this comparator right here that uses the integer as its data type, right? So by creating that, that's how we make it so that the compare method inside of this random class is used in the tree set to actually order the stuff aside, right? So that is how we do it. And it is what you will want to know how to do because that's how we use it. But essentially that is what it is. And then over here are some comments. Again, this is how you use a comparator in a tree set. So now you know what those empty parentheses were for. This one's specifying that these two have to be integers because like, again, you have to match these, the whatever is inside the angle brackets with whatever is here. All right. Let me know how you're doing. Scale of 1 to 5. And you can like send your number in whenever. Hopefully send them. Yeah, scale of 1 to 5, 5 being I know everything. Or like you understand everything. Okay, that's fine. Let me know how I can help though. Okay. So the thing with this then is that if you're not going to use the comparative class as much, then you might want to do something with following, right? So the thing with this, right, you might say, okay, well, why do I have to continuously create another class each time I want to use the comparator, right? That's a bit too much work. And I mean, like, that's a valid concern, right? Because like, you don't want to, if you had multiple different ordering methods, then you don't want to like continuously create more classes upon classes if you're only going to use it once, right? It's not worth the time and effort. So therefore, if you're not going to use as much, the class as much, that is, there's another way of using comparators still, but then still using it. But like, if you're not using it as much, then it's a condensed way programming it. So that is, or just need to space this out a bit. So what you see here is, looks very complicated. But if we only look at that part, right, what we see is we're saying comparator, integer. So pretty much, if you think about it, like pretty much exactly the same way we would implement a tree set, right? It's pretty much the exact same format. We're saying something that the name of whatever we're doing, right? So in this case, it's tree set. In this case, it's comparator. And then we both have the second part, right? We both have the part inside of the angle brackets. And they're both specifying a data type, right? Because it's a generic class or generic interface, depending on what it is. Right here, like with like pretty much every single formatting for variables, we have the name of the comparator in this case. And then like other objects, we're saying equals new comparator integer. That should be pretty familiar. We have parentheses here. And then what you see is curly brackets, which is kind of confusing at first, but like it gets more familiar later on. It's hard to remember the syntax at first, but I think as you practice, it gets a bit easier, and it makes it a lot easier to remember if you're thinking about like the different familiar formats, right? So like if you see new comparator integer, well, that's just saying creating an object, right? It's saying new comparator integer, which matches right here. But anyways, you have these curly brackets, and inside of here is something that also should be pretty familiar, right? If we take a look at this, it looks pretty much exactly the same thing as the one over here, right? The one that we're just going over where it's in a class. It's like essentially the exact same thing. Therefore, what it is kind of doing, right, is that essentially by doing it this way instead, we can essentially just put the compare method inside of here and just like be done with it, right? Like it's going to still do the same thing. Therefore, what happens is that we can still use it. So if we make a tree set of integer, and then inside of the parentheses, we put a now. Remember that this a would reference this thing right here, the comparator. And so now we still get to reorder everything inside of the tree set, but we can still make it so that like everything's more condensed and not as complicated. Where's my cursor? So yeah, that's like a main key difference. And I think, yeah. Okay, I guess just like a poll question, but give me a 1 if you think that you would prefer to use the first method of making a comparator if you're not going to use the class as much. Or would you prefer doing number 2 if you're not going to use the comparator thing as much? 1 or 2. That's fine. Yeah, generally it is good to use anyways. Yeah, generally it is preferred to use this one right here instead, just because it's a lot condensed and this all goes in the main method, right? So that means that you don't have to deal with classes as much. All right, next thing. So again, this thing would go in the main method. It'd be useful for if you didn't want to create a class comparator. But if you didn't want to even create a variable, you can also do another thing. So let's say that you're doing a tree set integer and you had a tree set. Now, this is going to look extremely confusing, but oh no. I apologize. I can't even highlight. But essentially inside of these parentheses, what we're doing is essentially transplanting the whole thing inside of the parentheses that the tree set has. So you can see here we're saying new comparator integer, which again, if you only look at that part, that should look pretty familiar because it's like an object creating. We have the customary parentheses that we always have when we want to do like creating a new object, right? Then we go directly into the curly brackets. Code continues, sure. But yeah. So you can see here again that like very similar to this other one where we were creating a variable, we're also doing the same thing here. We're literally putting curly brackets and then we're directly putting this, the compare method in, right? Like it's the exact same thing as in the variable format, like this format, and as well as in the class format, right? It's the exact same thing. We can still put the method here, even if it's not in a class. So yeah, you can see it's the exact same thing. Brackets get a bit confusing sometimes, but you just have to like match it up. So like, for example, this curly bracket right here corresponds to this one right here. And then this parentheses right here corresponds to this second to last one right there. And then the semicolon just ends it off because you always need a semicolon when you're saying statements. But yeah, so if you already use the comparator, then you don't have to use the comparable interface, because like if you're already using an ordering method, you don't really need to use it again. But the thing with this, right, is that again, comparable is more for if you're trying to implement an ordering for your own class. Comparator is more for ordering, like reordering primitive data types. So if you keep that in mind, then it should help with differentiating. I'm gonna zoom out of it. So I'm talking about like these kind of 3 different variations. They all do the same exact thing. It's just that the length differs, right? And there's different ways of programming them. I would say that if you're only going to use a comparing method once, then do the third one, right? Oh no, I hope I don't like mess this up again. But yeah, do the third one if you're like only going to use it one time, right? Because you know, it's very short, right? Like it's all condensed into one section. You don't have to deal with it again. And the thing is, like, if you're going to use it multiple times then, and you're doing the third format, then you're going to have to copy and paste the same exact thing, maybe with like slight variations, to multiple different tree sets. And that like just creates redundancy, which is essentially just like a lot of different code that is like essentially the exact same thing, which is not good because then it becomes hard to tell apart your code. And yeah, it's just not a good thing. And it's hard to change later if you like suddenly decide you wanted to do a different ordering. So yeah, that was a kind of like a long answer, but essentially only use this way of comparing for the comparators if you're going to only use the comparator one time. If you're going to use it like 2 or 3 times, then, or like maybe like even 5 times, then use the variable format, because then you can still use it again, right? Because you can see how easy it is to just say a for like a variable name and then be done with it, right? Because you're already using the comparator thing, but like you already specified that in a variable, so it's very easy to do. So this is if you're gonna do like 2 to 5 times, let's say. If you're going to use it more than that, then I would suggest creating a class for it, since that way everything's organized. The stuff that's used a lot can stay together, and yeah, it's worth the time and effort then if you're going to use it that much. Okay. Any questions? Alrighty, let me know. All right, those comparators would essentially sort everything in descending order. The thing, like I was saying before, is like to make your comparator consistent so that everything is orderly inside of your tree set. So for example, like this is like putting it into words, like visual words, like what I was saying earlier. If you enter compare AB, right? Like, because that's how you would call the methods, right? Because remember that for these compare methods, you have to enter compare and then 2 things. But like you wouldn't do it because you probably wouldn't want to do it. Like there's not really much of a point. It's usually more like the tree set itself does that. But let's just say that you were going to do it yourself and you entered compare AB and it returns -1. Then when you enter compare BA now, like if you swap the order of those 2, it should return 1. If you don't have a consistent ordering, then an exception will usually be thrown. So something like the thing I had with mine, where let's see, it was something like mine right here, you see, like, that's not very consistent ordering, right? So that means that most likely there's going to be some exception thrown, because like that is just not a good ordering. And like the point of having ordering is so that there's an order, right? Like if it's very hard to tell the ordering, then like there's not really much of a point in it, unless you wanted to make it random. And this is kind of like a random slide I put in, but I'm probably going to transfer it to the other document at some point. But essentially talking about string comparison, which is very similar to what I was talking about last time. So let's say that we wanted to create a tree set of string now. And yeah, you can see like this is the exact same structure that we were doing just now, which is saying new comparator string, parentheses, curly brackets. And then we have the compare method still, right? Like we're still putting the compare method. Now we're using string A, string B, because again, whatever data type inside of the angle brackets should match whatever is here. And then we have if A dot compared to B is greater than 0, then you return -1. So essentially like return the opposite. Else if A dot compared to B is less than 0, should return 1, because that's the opposite if we wanted to do reverse ordering. Or if A dot equals B, then you can return 0 for equality. And this is just a return statement just in case anything goes wrong. Or if you wanted to do it even shorter way, the compare method would be something like this, right? So you can just say B dot compare to A. That's simple. Because then it would use the string compare to method and it would just compare the opposite, right? And because how we talked about how if you enter a certain AB, right, back here, if we enter a certain AB for compare method and it returns -1, then if you enter the two values swapped, then it should return the opposite value. So this is kind of doing the same thing here, right? We're saying that if we swap the ordering of the two, then it should enter, like, return the opposite thing. And that's what we want to do because we want to do reverse ordering. So yeah, again, it sorts in descending order and it uses pre-existing dot compare to methods. And so that like makes our life a lot easier because we don't have to like actually manually compare the strings now. Like we don't have to parse what each character is and then like compare the two. Okay, doke. Any questions, Tony? That should be it for our lesson though for today.